Ladies and gentlemen, we will continue with our second talk, which will be focused on testing on mobile devices. Now, do you have a feeling how many mobile devices are out there? Anybody willing to shoot a number? How many? How many types? Tens, hundreds, thousands? I don't know. I use an iPhone, but I've heard from my friends that all other kinds of mobile devices, and this poses a problem for testing for mobile developers. And the next talk will be focused exactly on that, allowing developers to test their user interface of their software for various kinds of mobile devices at scale. The speaker is our dear guest who came from Microsoft, and he's an interesting guy. I'm sure he uses mobile devices quite a lot because one of his hobbies is geocaching. Not just he's playing geocaching, he's also creating geocaching games. He doesn't need to go to those places, he just creates it virtually and lets other people to go to all those places. And what he's doing, what his job is to investigate the hottest technologies and introduce them to developer communities in Microsoft. The title of the talk is Mobile UI Testing at Scale. And please help me welcome Mr. Martin Simecek.
Thank you. Thank you very much for this warm welcome. I didn't expect that, honestly, so it's great. They asked me to talk to you about how Microsoft and Xamarin together are allowing developers to UI test their applications at large scale. So by the end of this talk, I hope you will understand that mobile UI testing can be hard. It can be actually very hard. But on the other hand, there are technologies which can help you with that, make it more easy. And just to get an understanding, how many mobile developers are there in the room? Can you raise your hands, please? Good. So, good news for you, I will show some code. Good news for the rest of us, not that much. Let's start by introducing you to Martin. Martin is a mobile developer, and he's creating an app which runs on iOS, Android, and Windows. And it's a small app. It's basically an app for his friends and, let's say, 100 people who download it from the store, some of them by mistake, but that's another story. But still, it's a small app, and he's developing it on its own. And for those of you who aren't mobile developers, let me just briefly introduce you to the flow he's using to develop and test his app. He starts by thinking about a feature, then he implements it. And after each iteration, after basically each line of code, he needs to test that it's valid. So what does he do? He runs a simulator on his own PC or a Mac, but Martin is using PC. And every time he implements a part of the feature, he just runs the app, shows that it works, then continues developing, then runs the app again, sees some bugs, fixes them, and so on and so forth. So this is how he implements the feature. Once he's confident enough that the feature set is sort of complete, he then packs it as a package and sends it to his friends so that his friends can suffer from his mistakes and test the app for him. And usually, because Martin is a little bit introverted, it's like 5 to 10 people, so it's tested on 10 devices at most. The problem here is that most of Martin's friends are geeks, so their devices are high-end and all updated to the latest versions. The latest versions of Android, the latest versions of iOS, latest versions of Windows. And he can be certain that on those versions, the app works fine. And for him, that's okay. So he goes ahead and publishes the app to the store, and it's done. It's out there. 100 people downloads it. Sometimes it works, sometimes it doesn't. No big deal. One day, a report comes that it doesn't work on some version of Android, and he's like, meh, it works on my machine, you know. And he just claims it unsupported, and that's it. Time goes by, Martin gets more skilled, and he gets a job. He gets a job at a larger company. It can be, let's say, Alaska Airlines, who are creating an app for their customers. And now we're moving from 100 to 1,000 or 10,000 users. Martin is a little bit nervous about this. But what can go wrong? He will do what he's always been doing. So he will write the code, test it in the simulator, doesn't work. Write the code, test it in the simulator, works, great. Finish the feature, tests the app with his colleagues. Let's say that's 20 devices. Good, works. Goes to the store, gets downloaded. After a while, strange reports start pouring in. There's one certain Galaxy S3 which has problems. The login screen doesn't work. People can't get in. And Martin's like, wait a minute. John here has exactly the same Galaxy S3 and it works on his device. So he tests it again, it works. He looks at the report, no, it's really Galaxy S3. And then he notices that it's running a different version. It's the same device with a different version of Android and another different version of firmware. How could he know? How could he test this? So after a while, he gets the device, he tests it, there's a bug in the system, so he knows how to overcome it. Good. Another day, another report comes in. Shushinomi 587 is having the same problem. Shushinomi, what? Does this device even exist? Well, someone in China is using it. How do we get it? It's unable to buy in the Czech Republic or in the US. That's a problem. So we just call it unsupported. And you can see the pattern, how this works. And actually what Martin has hit is being called the Android fragmentation. You probably don't see it from the back, but these are different versions of Android being run in year 2015 on different devices by different manufacturers. It's based on a survey or a research conducted by OpenSignal. You can Google that and see the full results. And it shows the real fragmentation of Android around the market. And you can notice that we have Galaxy S4 twice, or even more, I don't know, but they are next to each other. So there are two different versions of the same phone out there, and people are using them. How do you test for this? That's crazy. And we're got used to over time to have poking on Android for fragmentation, but if you think about it, iOS has this problem too. Because it's not just about the phone, it's not just iPhones. There are iPods, iPads, there are new versions, old versions, there's 3D touch, there's multitasking. There are a lot of things you need to take into account when designing a user interface for your mobile app. And buying all those phones and having them, it's possible. I'm not saying it isn't, but it's very difficult to keep up. Because one day there's a new version of iOS. What do? You go stop into the line and wait for it? Probably not. So you will wait until you get the device. So Martin realizes that he needs to do things a little differently. So he starts his research. Thankfully, Alaska Airlines is using Xamarin. So he's used to this, and he knows that there's a framework. It's called the Xamarin UI test. And it allows him to write UI tests for his apps in C#. He knows C#, so this is great. So he learns it, he knows how it works, and it's great for testing on his machine. So each time he implements a new feature, he can run the test and go through all those tests, very quickly, automatically. But what if it doesn't solve the original problem, the fragmentation? So what if he wanted to test it on this exotic device? There's another service, and it's called Xamarin Test Cloud. Xamarin Test Cloud is a service offered by Xamarin, which is now Microsoft, and it has 2,406, as of yesterday, physical devices in a data center in Denmark, and they allow you to take your app, take your UI tests, and submit them to those devices. And it basically works like that. You just select, I want this Asus, that Acer, this Kindle, and blah, 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 and you send your tests to this device. Wonderful. There are more than 2,000 of them, and what's very important is that the devices wipe after each test run, which means that every time you start a test, you start clean. There's no data from other customers or other users. It just goes from 0 to your test, to finalizing the test, and then again to 0. And because I didn't want to torture you by watching me type and code, I asked Martin actually to record a video of how the tests are being built and how are they sent to the test cloud. So let's see this. Martin is using Visual Studio, but that's not a necessity, but he's preferring it. And he's using Android emulator on Windows. It's running Hyper-V, and it's quite fast. And he's built a very nice app, beautifully designed, very complicated and complex. You may recognize it because it's very popular around the world for some time already. And yeah, it's a calculator. There are some basic operations and the clear. Now, we want to add some UI tests for this app. So let's test some calculations. This is just proof that it's running a real operating system, real Android. And adding a test, a UI test, is very simple, and it's the same thing as adding a unit test, for example. So we add a new project, it's called a UI test, and it generates this basic template. This is here to show you that it can work on both platforms, Android and iOS, so you can write the test only once and make it run on both platforms. It integrates with Visual Studio in the Test Explorer, and this is just the first simple test which shows us that it actually works, that it runs. So something happens when we run the test. It will now take the application, take the package, and deploy it to the virtual device, to the simulator. We'll see it run in a second. Or 2 seconds. And it's done. So now this test passed. It's green. Great. Let's do something more complex. And to do that, we need to figure out how each of the elements on the screen are represented in code, in actual code of the device. So what we do is we say app.REPL. REPL is read eval print loop, and it opens up a console window which allows us to directly communicate with the app and with its user interface. So it redeploys the app again to make it clean. And after a second, it will run the console window. And this is a simple tool which is connected to the emulator, and it can directly communicate with it. And there are only, let's say, 4 commands, maybe 5. Help, copy, tree, and quit. And the most important is tree, obviously. It will show us what's going on the screen. So we can see each of the buttons, the numbers, and some labels, and this is what we'll use while building the test. And then we can just make some of the pieces of the user interface flash. So we will now place a selector for something which has a text of 0. And let's watch how it will flash. It's the first flash and the second flash. So in this case, we have 2 elements which contain a text of 0. This may actually present a problem when building the test further, because we're not using IDs, we're using texts. But let's not get bothered by this by now, and tap something, tap a button. So we're using C#, we're using selector, and we're looking for something which has a text of 9. So it will tap 9. Let's go ahead and tap plus, and 1. And then, wait for it, equals. and the result is 10. Now we want to check for it. We want to know that the test was successful and that the result is indeed 10. And we will use the wait for element for this. But we're not sure how to ask for it. So again, let's do 3. The interface has changed slightly. So we now know that there's something which has a class of forms text view and text 10. So let's make it flash first, just to be sure. Now we're very specific about it because we don't want anything which has a number 10 on it to flash. So we'll use the class selector. Boom, that's right. And tap it or wait for it. The test is done by now, so we can copy it to the clipboard. So copy is the right command to do that. And when we get back to Visual Studio, we'll create a new test and just paste it in. So let's call it something understandable, like simple calculation, okay, and paste it. So this is the basic UI test. We will clean it a little bit by now because we don't need flashes in the actual test because we won't see them. We just want the results. So we will delete the flashes and add 3 screenshots. And the screenshots will divide the test into phases. So we will be able later on the results see what happened after each step. So right now we're adding screenshot for 9 entered. Then we'll do after 1 entered. And finally, when the test is done, we want to see the final result. So it will be the final result. Bear with Martin here. He was a little confused when recording it. So there will be some changes and editing. And this is the right placement. So this is it. This is the basic UI test. We can now build a project. It will show up here in the panel. And we can run it. And it will, again, redo everything we've done so far, click the buttons, wait for the results. So you get the idea. We can have 10, 20, 30 tests. We can run them automatically, just as we run the unit tests after building each feature. 9 plus 1. Yes, and it's green. Great. So we made first UI test, which runs locally. Still doesn't solve the problem. So we will now send it to Xamarin Test Cloud. We can do this directly from Visual Studio. There's a command for it, run in Test Cloud. It will, again, pack everything, pack the UI test, send it to Test Cloud, and run it. It's using command line interface, so you can do this from, you don't even have to use IDE for this. You can do this manually. We can see it upload, and it will open a web browser and show us the test. So this is the Xamarin Test Cloud portal. It's a web-based portal, but there's an API for it. You just log in and select the devices for your test. And this is it. This is the magic. This is what's most important about the Xamarin Test Cloud. These are all the models and different versions of the devices that are available for you. And it's up to you to just pick. Do you want, let's say, LG G5 or different version of LG G3 from US carrier, or this version of Android or that version of Android? It's there. What's also there are waiting times, because there are only 2,400 devices. Some of them are more popular, so you can just say that you want to test it quickly. You don't want to wait. So you select the least favorite devices, and you will not wait that long. And you can just list different versions of Android in case there are problems on certain specific version of Android. And we are using now 444, 1+1, some carbon sparkle, whatever that is. And we will run the test. Now, our great friend Justin noticed that we're there. Unfortunately, no time to chat with him. And the test will now run. It takes a few minutes, so there'll be cuts to show you the results. It validates the package, runs the test on all the devices you selected. So if you select 10 devices, it will run longer, obviously. So in this case, it was 10 minutes. We see that none of the tests failed. We tested it on 3 devices on a single OS version. These are the results. This is the first test, just launching it. And these are the screenshots we have specified as simple steps. And we can see in each step what was displayed on the screen. And we can go deeper. We can have a look on the specific device. We can have a look on device log. And we can also see what was the memory usage and CPU usage at that very moment. If there were errors, we would usually get a stack trace, so we will know what exception caused the error. And since these are really physical devices, it sometimes happens that it fails because of the operating system being updated, for example. It's just a real scenario with real device, so it can fail for this reason. Good. So you've seen how to do it manually. But Martin is an enterprise developer now, so he needs to do it in a more automated and more professional way. He needs to rub a little bit of DevOps on it. He needs to integrate it continuously. So how will we do that? We can actually use Visual Studio Team Services for that. Visual Studio Team Services, if you're not familiar with it, it's another cloud service from Microsoft, and it serves as a code repository, but it can also be used for automatic building and automatic releases. So every time someone from the team checks in a new code, it will build the app, send it to the test cloud, do the unit tests, and then finally send it to Hockey App, which is another service being used for distribution. And just to show you how the definition can look, this is a basic build, and it has several steps. First, we will restore NuGet packages, then we'll build the app, build the tests, send it to the test cloud, and we're sending it to those devices. These are the 3 phones we have selected. It's been hashed to a few characters we will use, and we can select a few different options. Once this is done, and only once this is done, we will sign the package, publish it to drop, and then publish the final APK to Hockey App to make it available for other people or beta testers, for example. This can be part of build, and it can be part of release. So if there's, let's say, a release manager who wants to make the beta version tested every day or every night or every week, he can do that from this interface. The code right now is hosted right in Visual Studio in Git repository, but it can come from GitHub, it can come from any other source control out there. So this is the DevOps part. And this is the result in Hockey App. Let me show you only quickly how the actual run is looking. These are the results from the test, so we can see how it went, and we can also see pretty much the same thing we had in Visual Studio. This is uploading, validating, running it, and here we go. This is the report. All automated, no need to do it manually. So Martin is now an enterprise developer. He can work with Visual Studio. He can develop the code in there. He can test it in Xamarin Test Cloud on 2,000 and more devices on his behalf. He can build it automatically in Visual Studio Team Services, and he can distribute and monitor crashes from Hockey app. Quite good. But there's more. There's one more thing. What if Martin or someone else doesn't have the source code of the app? Or what if the app isn't even written in Xamarin? It's just an APK widely downloaded from somewhere from the internet. Or it's downloaded from Hockey app for testers. Or what if Martin is actually more visual than a coding type? There's Xamarin Test Recorder for this. So I will briefly show you a quick demo of Xamarin Test Recorder on Mac. It's a tool you can use to do pretty much the same thing I showed you first in Visual Studio. In this case, we're downloading the package of the app from Hockey app. So there's no source code whatsoever. You just take the package, take the APK, download it. It's the latest build. It's been downloaded. And you can run the Xamarin Test Cloud Recorder tool. Select the device you want to run it on. It can be a physical device which is connected to your computer via cable, or it can be a virtual device as a simulator, which is what we're doing right now. So this is the version of Android Simulator on Mac. Again, it's a real operating system. And we're getting our APK package. It will be deployed to the device. And we can start recording. And whatever you do now with the app is being recorded as a UI test. So tapping 9, tapping plus, and again. We want to check it's really 10, so we're switching modes. And the test is done, so stop recording, and we'll do little tweaks. Just to be more specific again. So we want to say that the class is forms text view, and that the text is actually 10. Now you can see that there are screenshots being made after each step. That's a little too much. We don't need that much. So we'll reduce it a little bit by simply clicking. And this is it. The test is done. What we can do now is send it again directly to the test cloud, or copy it to the clipboard and use it in the IDE, which in this case can be Visual Studio for Mac or Xamarin Studio for Mac. And this is it. Pretty much the same result as we saw earlier, only a different approach. To summarize and wrap it up, we've seen Martin starting as a hobby developer at the very beginning, testing manually, testing on his friends, testing on 10 devices, simply evolving to an enterprise developer who creates apps for masses, for 10,000 users, and who is able to test his app on a variety of devices, different versions, different Androids, different iOS devices in the test cloud. And for you, it's what's written here. You don't need to own those devices. I'm a geek and I don't have 10,000 phones. I have only 6. So you usually need some tools to help you, and this is one of them. It's not the only one on the market, but I think it's pretty cool, and I would be more than happy to show you more closely how it works and discuss all the scenarios and possibilities. So thank you very much, and see you later, see you around.